Welcome to the Super Lab for IOD502, compare or combine data from a complex data presentation. Before you get started watching the video, you should make sure that you have the IOD502 skill sheet in front of you. You should also have a pen or pencil, obviously, so you can follow along with us. We're going to request that you pause the video at certain times so you can go through some work on your own. Make sure that you pause work and then press play when you're ready to go. Let's get started by taking a look through the background information on what skill we're actually looking at here. IOD 502 is the single most commonly assessed skill on the science ACT. Graphs and tables on the ACT often seem to be really complicated, but they aren't. All you need to do is carefully examine what they're trying to tell you. When you need to complete a skill, like comparing data in a complex data presentation, just try to pick out what you know. Most of the questions will tell you which figure or table you need to look at. Only use that one figure or table. Don't worry about the others. All right, this is where your halt skills really come into play, because a lot of times you'll see crazy looking data and it's really not that bad if you can halt it. Let's get started by taking a look at the passage. When we tackle a passage, the biggest thing that can get in our way is vocab we don't know. All right, we learned 3 different ways to tackle that vocab. The 3 different ways we tackle that vocab: first, sometimes it's defined for you in the passage, either with a comma or in parentheses. It'll tell you what the word means. The second way is you can use context clues or background knowledge to try to figure out what it means, because maybe you've heard something like it before. The last way is to look it up. In the ACT, you can't use a dictionary, so we avoid that method. We're going to go through the the passage now. What you should do is, as you are listening, circle, highlight, or underline any words that you would stumble over. So words you don't know the definition of, you've never heard the word before, you're confused about what it actually means. Any words like that are what you want to circle, highlight, or underline right now. All right, let's get started. Glaciers deposit till, poorly deposited or poorly sorted sediment. If glaciers repeatedly advance over an area and then melt back, thick till deposits may form. Figure 1 shows a vertical core taken through layers of till, non-glacial sediments, and a bedrock at a site in Canada. The resistivity, an electrical property of a material, and carbon dioxide measurements taken along the core are also shown. Resistivity is related to a sediment's particle size, compaction, and mineral composition. Table 1 shows the average percent of sand, silt, and clay contents and descriptions of the various till layers. Taking a look at that layer, or that phrase, I should say, are there any words that people circled, highlighted, or underlined that we'd like to circle together now? Resistivity, that's a good one. Till, that's a good one. We have till and resistivity as the new words maybe we haven't really come across before. Any other ones? Words going once, words going twice. Words sold. All right, so remember we have 3 tactics. The first one is till. First thing we check for, did they define till for us in the passage? Yes, they did. It's actually in parentheses. Till, the definition is right here. Poorly sorted sediment. All right, what we mean by sediment is essentially dirt and rocks. Now, watching at home, you probably can't see the prop that I'm currently holding in my hand, but it's a tube that's full of different layers of dirt. And you can see that it separates out based on its size. So you can look at sediment, and sediment will actually form different layers. And then if you mix it up, sediment will remix with itself. Eventually, if you let it sit long enough, the sediment will eventually layer back onto itself once again. All right, so this is what we mean by sediment. Sediment is just any rock, dirt, or debris that's kind of layered in the ground. So if you were to go outside right now and go into the park and start digging, all right, the first layer that you dig through is like really loose black soil. You'd get a little bit further and you'd hit kind of more rocky soil. And if you went even further, you'd start to hit sand if you went down far enough. If anyone's ever dug a hole before, all right, that's eventually what you hit. But those are the different layers of sediment that you'd expect to find here in the city. All right. So till is an example where it's poorly sorted. So till is like if we took this tube that was full of sediment, and instead of having it nice and evenly layered, it was totally mixed together. And that's what we're talking about here. So it's really impossible when it's all mixed up to tell what percentage was sand, what percentage was a really light silt, which is really tiny, tiny material, and what percentage was rocks or pebbles. And that's what we mean by till. So it's just when it's all mixed together and not well layered. All right, the next word we have is resistivity. All right, resistivity again is defined for us in the passage. It's an electrical property of a material. Does anyone know what we mean by the term resistivity? If a substance has a high resistivity, it's an electrical thing. What does it not do well? Something with a high resistivity. Have you ever heard that word before? It doesn't let electrical current. Nice. It's not. It doesn't let any sort of current flow through it. All right. So things like rubber or wood or glass have a very high resistivity, meaning electricity doesn't flow through those things easily. But like metal, like copper or salt water, all right, those conduct electricity really easily, and so they have a very low resistivity, all right, because it lets electricity flow through. Okay, so that's the passage, and so let's start to take a look at the data. All right, the first data table that you see is table 1. If you flip back to the passage, it'll tell you what is in table 1. At the very end, it says table 1 shows the average percent of sand, silt, and clay contents and descriptions of those various till layers. All right. Mm-hmm. Question? Yeah. So there's kind of varying strategies that you're going to use on the ACT. One of the things, the point of the preparation that we do together is like the real purpose of skill sheets is bigger than just the ACT. Like the real purpose of skill sheets is to get you these skills that you'll need eventually someday. So you'll need these skills to be able to like look at a table, analyze a table, be able to look at a graph, regardless of the field you're in. Like if you study sociology, you're going to have to look at a bunch of data and analyze it. If you're going to go into biology, you have to look at a bunch of data and analyze it. No matter what the field, you'll have to do something along these lines. So really the point of skill sheets is more like the general building of that skill, which means you would want to read the passage. Now there certainly are questions on the actual ACT test that you won't necessarily need to read the passage for. In this case, I wouldn't suggest practicing that kind of stuff. That's a little bit better on actual practice tests that you'll take at the school. In this regard, I would really try to push everybody to really look at the whole experiment and try to figure out what's going on. Because the other reason that's helpful is you're going to see some new questions on the skill sheet quiz that having already some good background information will help you answer those. But you're right, on the actual ACT test, you don't always need to read the passage. Good question. All right, so if we take a look at table 1, there are 5 different variables being shown in table 1. Can anybody outline what one of the variables that is listed in table 1 would be? What's being shown in table 1? Nice. So the layer that we're looking at, we can figure out that layer's depth. What else is in here? Nice. What would we call it? All right, what kind of till is it? Now the next ones are a little bit trickier. All right, there's 3 more. All right, what are we looking at? And what about sand, silt, and clay? They're what? Nice. And so essentially the way these 3 work is all 3 of these columns are actually represented by this one heading at the top. So all 3 here, here, and here essentially are percentages of the till layer. So where it says average percent by volume of, what we're talking about there is, so for this layer, what percentage of that layer is sand, what percentage of that layer is silt, and what percentage of that layer is clay. And if you do all of the additions, the percentages should add up to what? 100. All right, because till is made up of sand, silt, and clay. So if you add up the amount of sand, silt, and clay, hopefully what you'd get is 100 because that's the whole layer. All right, so it's just telling you for each layer how much is each one. Okay, any question on table 1? Let's flip to table 2. I'm sorry, figure 1. Figure 1 is where it starts to get a little crazy. All right, figure 1 is a little nuts. But if you kind of take a step back, what you'll see is that figure 1 is actually 3 different graphs all crammed together in one supergraph. All right, there's 3 different graphs here. What would be this is a tough one to see, but what do we think would be the independent variable here? What is the constant through this whole thing? So the surface is at the top. You're right. That's always. So the depth is actually going to be one of our dependent variables as we look through this. And this is kind of tricky. Resistivity is actually going to be another dependent variable. And there's three of them. Yeah, and the tough thing about this is the independent variable isn't even labeled in here. Like there's no heading for that. The thing that you have to see is that this whole section right here is the independent variable because all of the other graphs depend on which layer you are looking at. So it's really three different graphs put together because you could find the layer versus depth, you could find layer versus resistivity, and layer versus CO2 concentration. But it's tricky here because the independent variable is actually not even labeled anywhere, which is why this can be kind of tough. Mm-hmm. It had to be in the question. Part of that skill is using new information they give you in there. Yeah. Or you could also come with it. Like eventually, what we'll see is that the lower they go, the older they are. So like new layers only form on top, which means the bottom layer has to be the oldest layer. And so we'll see that later. But yeah, it also could be knowledge you just bring with you. All right. So as we start to take a look at this, then what you could find is for each layer, its depth using this side, its resistivity. Now, finding its resistivity can be a little tricky because the graph is like sort of shaped weird. Like it's not a real graph. All right. But what you'd have to see is for, let's look at brown till. For brown till, its depth is pretty easy to find. All right. Look over at the depth side. Brown till is from here to here. So it's somewhere between like 5 to 9 because here's 0 and here's 10. So I'd say it's probably somewhere between 5 to 9 meters. All right. But what is its resistivity? What is the resistivity? How'd you get 20? Nice. So resistivity, we have to use this line right here and trace it up to the top to figure out what the resistivity would be. And again, you got to use estimation. So like here's 0 and here's 50. Halfway would be probably about right here, which would be 25. And it's a little less than 25. So somewhere around 20 is a good estimate. All right. Whereas if we were looking at gray till C, it'd be right here. Trace it up to the top, 90-ish. And you could do that the whole way through. All right. You could also do the same thing. Like, what if I asked you what olive, green, and gray tills CO2 concentration was? That's the last one. 11. So olive, green, and gray right here. Trace it up. It's just a hair above 10. 11 milliliters per gram is a pretty good estimate. All right. And so the important thing to see here is that we're looking at three different graphs. This is the CO2 part. This is the resistivity part. And this is the depth part, all compared to this, which is the independent variable for the whole graph, which is crazy. This is a complex data presentation. Whoa. Okay. Now using this, now that we feel comfortable, any questions on this one before we move on to clarify this graph? All right. So let's keep on pressing to the example question. According to table 1, which type of till is located the deepest in the earth? If we're looking at deepest, which variable are we going to want to try to find in the graph? Nice. Depth of till layer. And do we want the greatest depth or the least depth if we're looking for the deepest? Nice. So depth, and we want the deepest one, which is all the way down here. And that would be then which one? Grady. You could also use figure 1 for this if you wanted to. All right, because depth is also listed on there. All right. What you want to do right now is you want to, we actually went through most of the halts, but just fill in the halts pretty quickly for both tables to make sure that you have it. If you are watching this video at home, you should press pause now, fill in the halts, and press play when you are ready to go through the halts. All right, we're going to go through the answers to these now. As long as you have finished the halts already, you should press play. If you're not ready with the halts yet, you should repause because we're about to go through them together. As we start to take a look through, we filled in some of the basics of it, but let's just jump quickly to the trends. All right, in terms of the trends, can anyone give me a trend for table 1? Remember, trends can either be variable relationships, can be high points, low points, points where two numbers are the same. All right, any sort of trend that you would have here. Let's see, we have as depth decreases, we said percent of sand. You said decreases? Depth increases? All right, so as the depth of sand, as the depth increases, sand decreases. So then the depth moves down this way. So we would expect the sand to get lower. 54 to 48 is lower. 43 is lower. 37 is lower. 25 is lower. But this is the trickiest part. So I'll tell you right now, on the actual ACT, this was one of the questions for that reason alone, because this stumped probably about a third of the students who took it because they stopped after a few. They're like, oh, it's getting lower. It's getting lower. It must get lower the whole way. And that's why they write this question. Because what happens at the end? Yeah, it jumps back up. Right here, we see it switch to an increase. And I'll tell you, there's probably about a third of the students who took this ACT that got it wrong because they were like, oh, it gets lower, 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 and then just stop looking because it must get lower the whole way. So as sand decreases, then increases. That's good. It's good to be able to recognize this because we can fix it now and it's not a big deal. Good. Let's go to the other figure. Any trends that anybody noticed here? All right, so as resistivity increases, so as we kind of follow this line that way, and we see there are small fluctuations here, like this one goes up and then sort of back down again, and then up and then down a little bit. But if you use that term like for the most part or in general, it does imply that like these little fluctuations, you can sort of ignore that part along the way. So as this line moves this way, you also see this line. You said this line does what? So it gets warmer. So we'd expect this one to move this way as well. This one's a little tricky. I'm not totally sure that this one works just because of the amount of fluctuation from here, then to here, then here, then here, then here. But what does increase? In general, as resistivity, as things get more resistive, what else increases that way? The depth. Yeah, you could definitely say that. You could say as the depth increases, in general, the resistivity moves this way across the sign. Yeah, that's a good one. You can all use highs and lows, like sand and gravel have the highest resistivity, you could say. Nice, good. All right. What's going to happen now is in your teams, you want to answer questions 2, 3, and 4, and 2, 3, and 4, and 5 with your teams. You're going to also do this at home. Once you've answered questions 2, 3, 4, and 5, you should press play again so that you can go through the answers. But right now, until you've answered them, press pause and try them on your own. Good luck. If you are pressing play at this point, that means that you are ready to go through the answers to questions 2, 3, 4, and 5. So let's get started with question 2. According to table 1, does gray till A have more silt or clay? All right. First off, which table are we looking at? Table or graph or figure? 1 says right here, means we only have to care about table 1. And we are looking for a gray till A. A good strategy that I would highly start to recommend to people is underlining in questions. It makes it easier when you go back to the question. You don't have to reread the whole sentence. You can just look for the thing that you're looking for. All right, so underline the variables that are important, and it actually will save you some time in the long run. Gray till A, gray till A. Does it have more silt or clay? Gray till A, silt. Gray till A, clay. It has more silt. Okay. Number 3, according to figure 1, does brown till or yellow till have a greater resistivity? All right, it's brown. So we're going to figure 1. We only care about figure 1. Brown till, yellow till, greater resistivity. Brown till, here, resistivity, 25. Yellow till, here, resistivity, 60. Which one has a greater resistivity? Yellow, 60 ohms. 4, according to the data, what is the depth range of gray till D? And they give you a hint. Look at we're looking for depth range, gray till D. All right, the first thing you need to find is the depth of gray till D. Here's gray till D. Here's depth. D starts here. D ends here. Starts at 55. Ends at 85. Has a difference of 30 meters. All right, so the hint says look at the depth where it starts and where it ends and subtract those two numbers. All right, now when they ask for ranges in questions, you should be able to go both ways. You should be able to either give the range or the subtracted number. And you'll know which one they're asking for because all the answer choices will either be one way or another. They'll all be either like 15, 30, 45, 60, and so you know you have to do the subtraction, or it'll be 20 to 30, 30 to 40, 55 to 85, 90 to 140, and then you should be able to do it that way as well. So range actually can mean two things depending on what kind of question they're asking you. Exactly. The choices they give you will show you which options you should choose from. It could have been either way. Yep, if you wrote 55 to 85 meters, you would have been correct in this case because that could have been how the question was written. Yep. Number 5, according to figure 1, does yellow till have more large particles or small particles? That's not the right one. Yellow till. Now, how do we know which ones are the large ones or which ones are the small ones? Right, so yellow's here. Large particles are on this side. Smaller particles are on this side. So which is the largest one? Sand. Which is the smallest one? Clay. So yellow till has 43.5 sand, 24.8 clay. It has more of the larger particle. Okay, what you want to do right now is go through 6, 7, 8, 9, 10, and 11 together with your groups, and then we'll go through the answers together. Right now, if you're watching at home, you want to press pause and go through the questions on your own. Press play when you're ready to go through the answers. All right, if you are pressing play right now, that means you are ready to go through questions 6 through 11. All right, for questions 6 through 11, if you are not ready to go, please press pause again so that you can finish them up. Question 6, according to figure 1, we need to look at figure 1, how much more CO2 does brown till have than olive green till? All right, those are the 4 things I would underline because that's what my eye should drift back to in the question. So figure 1, CO2, brown till, olive green till. We compare them. CO2 would be here for brown till and here for olive green till. And if it says how much more, you have to do the subtraction. It'd be about 22-ish minus 11-ish. Some of you are going to be somewhere around 11. Brown minus olive. Did you guys get more 25 than 22? Oh, 24 minus 11. All right, which actually brings up a really good point in terms of milliliters per gram. In terms of how these questions will be asked, remember that as long as you get close, that's what I would expect for you. On the actual ACT test, if we're thinking of that in terms of preparation, they're going to give you multiple choice answers. They won't give you answers where you have to be super exact. So they would give you choices like 6, 13, 20, or 42. And so from those choices, you would be able to pick out the one that's closest to your own. Number 7, which gray till, B or C, has a greater depth range? All right, has a greater depth range. So which one has a greater range? If we're looking at gray till B or C, here's gray till B. It goes from about 20 to 25. And gray till C goes from about 35 to 55. Which one is the greater range? C, because it's much deeper. It's a 35 to 55 is about 20 meters of difference. So that would be C. And order the gray tills A to C from greatest to least resistivity. All right, if we take a look for A's resistivity is here, B's resistivity is here, C's resistivity is here. It should go in reverse order. C, B, A. All right, it should go C, B, A. If you put A, B, C, you actually got tricked by one of the questions from this passage on the actual ACT in the year it was given. Because this says greatest to least, not least to greatest. Be careful. This was a tricky passage on the actual test. People got real mad. Okay. Number 9. According to table 1, how much more clay does yellow till have than brown till? All right, table 1, clay, yellow till, brown till. Table 1, clay, yellow till, brown till, brown till. 24.8 minus 14.2, because we're trying to find out how much more. And what do we get for a final answer? 10.6%. All right, so that should be 10.6%. According to table 1, olive till has how much more of the smallest particle compared to the largest particle? Table 1, olive, how much more, smallest particle, largest particle? Table 1, how much more of the smallest particle, which in this case is clay, and we're looking at olive till. So the smallest particle is 40.2. The largest particle is 25.5. 40.2 minus 25.5. Now again, you're not going to be able to have a calculator on this test. All right, so you have to be able to start to do this kind of subtraction on your own. 24.7, right? Did I miss one? 40.2 and 25.5? 40.2. Yeah, my number doesn't make sense. 14.7. There we go. Oh, 3. Right. Gotcha. All right. Any questions? Last but not least, according to table 1, which gray till sample A through D had the highest percentage of the smallest particles? Gray till A through D, highest percentage, smallest particles. Smallest particles are clay. We'll look at clay again. Here's A's, here's B's, here's C's, here's D's. Highest percentage, smallest particle is 34, which is C. Because 34 is higher than 30.8. It's also higher than 28.3, and it's higher than 18.6. All right, which means that gray till C is the winner. All right, at this point, you want to answer questions 12, 13, 14 on your own in your teams. You should press play when you're ready to go through these answers. According to, now we're going to go through questions 12 through 14 together. As long as you're ready to go through 12 through 14, keep pressing play. If you are not ready to go through 12 through 14, you should pause. According to figure 1, what type of till formed in the warmest climate? Now, we haven't talked about temperature yet, but where can you find temperature in the graph? Under CO2. You notice coolers on this side, warmers on this side, and the arrow goes that way. So, what type of till formed in the warmest climate? That would be this one, because it's further to the right than any of these other options here, which means that's gray till A. All right. In which till layer did the glaciers advance and then melt back the greatest number of times? Hint, read the passage. The part that you need to read is the second sentence of the passage. When glaciers advance and retreat over a layer multiple times, thick till deposits form. So every time every time a glacier goes back, a thick till deposit forms. So a glacier goes over and comes back, and you get a thick layer forming. Glacier goes over and back again, it gets thicker. Over and back again, it gets thicker. Over and back again, it gets thicker. So which layer is the thickest? Gray till D. Gray till D is the thickest layer. It has the greatest depth range, which means that the glacier came and went back the most number of times. What do you think? Exactly. The least thick then would be the least number of times. Perfect. All right. Last but not least, number 14. Since these core samples are, oh wait, we didn't put them in order. Oh yes, it was gray till D should have been the answer to that one. Last but not least, since the core samples are solids and they cannot separate based on their densities, the older samples are found below the younger samples. That means the older samples are found below. Below means lower in depth. Below the younger samples, which would be up here. Your oldest one then is going to be on the bottom, and your newest one is going to be on the top, because the older samples are found below the younger samples. All right, this means that your oldest sample is bedrock, your youngest sample is the surface sediments. So if you were going to put them in order of yellow, brown, and olive green, we have yellow, brown, and olive green. The oldest would be olive green, then yellow, then brown. From oldest to youngest, it should go up, up, and up. Right now, what you want to do is you want to press pause and answer the last two multiple choice questions, 38 and 39, before you're ready to take the test. Press play when you're ready. At this point, if you are pressing play, you are ready to go for questions 38 and 39. If you haven't answered 38 and 39 yet, you should press pause and finish answering those. The first one says, according to figure 1, which of the following statements best describes the resistivity of the sand and gravel layers and how it compares to the resistivity of the till layers? So now this is one where you're actually adding the second half of the sentence to make it true. So we have the resistivity measured of the sand and gravel layers is, so if we look at the sand and gravel layer here, resistivity here, that would be this, and trace it up. It's about 140. So which of the following is true if we added these answer choices to the end of the sentence? The resistivity measured of the sand and gravel layer is lower than the resistivities measured in any of the till layers, higher than the resistivities measured in any of the till layers, the same as the resistivities measured in any of the surface sediments, and lower than the bedrock. So let's see if they're true. F is lower, so the sand and gravel resistivity is lower than the resistivity of the till layers. We have, let's see, let's do the till layers in green. We have till layer here, here's a till layer, here's a till layer, and you'll notice that in this case there isn't a single till layer that's greater than the resistivity of the sand and gravel layer, which means that the statement, the resistivity measured of the sand and gravel layers is higher than the resistivity of any of the till layers. That's the one that we're looking for to be true. The average resistivity of the bedrock in the core is most similar to the average resistivity of which of the following? All right, we'll do this one in blue. So we're looking for average resistivity. Bedrock is most similar to the resistivity of which of the following till layers? Bedrock here, resistivity here, and here's the point. It's most similar to, let's see, the line is pretty close to this one, which is olive green and gray. It's also pretty close to this one, which is gray till A. And of those two, the only one that's a choice is olive green and gray till, which would be C. At this point, if you understood all these questions, you're ready for the quiz. If not, it's time to go back and take a look at some of these questions again in any part of the video. Rewind to where you need to go. If you're ready to take the quiz, good luck.